Welcome to an edition of CCSD Living Environment. In the last video, we looked at renewable and non-renewable resources, and we talked some about soil and water and what we need to do to conserve those resources. Today we're going to do a whole video about air quality and how can we conserve air as a resource. The quality of the atmosphere has a direct effect on health because, remember, it does provide the oxygen that we breathe. So our health is very much related to the quality of the air that we breathe in every day. In the upper atmosphere, a naturally occurring form of oxygen, which is called ozone, is found that absorbs harmful ultraviolet radiation from the sun before it can actually get to the surface here on Earth. So we know about the atmosphere that's here, but if you go way up into the stratosphere, hopefully you remember the layers of the atmosphere from when you did earth science, and if you go up into the stratosphere, you find that there's this compound known as O3. O2 is oxygen, O3 is ozone. Ozone does a really cool job for the Earth because as the ultraviolet rays for the sun, which we know are bad, as they try to come in, ozone basically deflects them back out into space. Now the big problem was when some of that ozone had been chewed away, because now those ultraviolet rays could get through. Three gases found in the atmosphere, carbon dioxide, methane, and water vapor, provide the balance between the heat that stays in the biosphere and the heat that is lost to space. If you remember those gases, carbon dioxide, methane, and water vapor, again, we're back to this concept of being a very delicate balance. And those three gases help to provide a balance so that some heat stays in the Earth and some heat can escape out of the Earth. We want it to be warm, but we don't want it to be too warm. The greenhouse effect, which I'm sure is where you could see this going. Greenhouse gases, and again, those greenhouse gases are carbon dioxide, methane, and water vapor. Greenhouse gases act like glass in a greenhouse, allowing visible light to enter, but it traps the heat inside. So those gases in our atmosphere allow the light to come through, that's why we see, but they also allow the heat to come in. Well, when the heat comes in, the problem is those gases don't let it back out. The same way the gas doesn't allow the heat to get out of the Earth, the glass in the greenhouse doesn't allow the heat to get out of the greenhouse. That's why we call it the greenhouse effect. If the greenhouse gas concentrations rise, they trap more heat, so the Earth warms up. If the concentrations fall, more heat can escape, and the Earth cools down. Without the greenhouse effect, our temperature right now today would be about 30 degrees Celsius lower than it is. And you say, wait a minute, I thought we had this whole global warming thing. Well, hang on, hold that thought for a minute. All we're talking about right now are just the greenhouse gases. And what is the greenhouse effect? The greenhouse effect and global warming are not the same thing. The greenhouse effect is caused because those gases, once the heat comes in, those gases prevent the heat from going back out. That's what keeps our planet somewhat warm. The atmosphere is never really used up. Now you could say, okay, well we used up all of the fertile soil. But you can't really use up the atmosphere. We can't use it all up. So classifying it as a renewable or non-renewable resource isn't as important as understanding how do our activities affect the quality of the atmosphere. So it's more about the atmosphere or air quality than it is necessarily about how do we clean it up or how do we use it all up. It's not a matter of all or nothing when it comes to atmosphere. It's really just a matter of how do we make sure that the air that we're breathing is clean and that the air that we're breathing isn't causing diseases or doesn't have a lot of pollution or junk, basically, in that air. Biogeochemical cycles have maintained the quality of the atmosphere for many years. However, human interruption of those cycles and bombarding the atmosphere with pollutants has had an effect on air quality. Biogeochemical cycles. What is that? Well, let's look at the word. Bio meaning living, geo meaning earth, chemical meaning things like carbon dioxide and water, nitrogen, those things, biogeochemical cycles. How are we cycling chemicals, oxygen, hydrogen, nitrogen, carbon, between living things and the earth that they live on? So when we talked about cycles before, really, they're biogeochemical cycles. This is just putting it together. Hopefully now you understand that definition. So we need to make sure that you have this idea that you can't necessarily use up the air. You can't use up all of the atmosphere, but you certainly can take care of it so that it's healthy for us to breathe that air. And that's where we need to go with air quality. Industrial processes and the burning of fossil fuels can release pollutants of several kinds. Common forms of air pollution include smog, acid rain, greenhouse gases, and particulates. And you're saying, wait a minute, I thought you just said that greenhouse gases were a good thing because it makes our planet kind of warm. That's true. But it's like with anything, when you have too much of something, it's not a good thing. So yes, having some greenhouse gases is there, keeps our planet warmer. Having too much of a greenhouse gas could lead to a problem. When the quality of the Earth's atmosphere has been compromised, respiratory illnesses like asthma are made worse, and skin diseases tend to increase. Believe it or not, the quality of the air that we breathe has an effect on your skin. And when you say, how is that possible? Well, your skin is touching that air all the time. And then there's stuff that's in the air. So if there's a lot of pollutants or other things in the air, it's coming in contact with your skin all the time. So between respiratory illnesses like asthma and skin diseases, we want to make sure that the quality of the atmosphere is pretty clean. It's good quality air that we're breathing, good quality air that's touching us. On a global level, climate patterns may be affected. So this would be local for us. Asthma, skin diseases, that would be right here what's happening. But let's go big picture. On a bigger picture, if our atmosphere isn't good, if it's not very clean, we could change global pattern changes. We don't want that. We don't want to change the patterns of the oceans, the patterns of the winds, the things that help to control climate. We don't want those things being changed. We want those things staying pretty much consistent. So let's take a look for a minute at acid rain. Acid rain means that the nitrogen and sulfur compounds released from burning fossil fuels, when we burn fossil fuels, it releases compounds that contain nitrogen and compounds that contain sulfur. Those compounds go into the atmosphere and they mix with the water vapor that's there. Once they do that, it actually falls from the air with nitric or sulfuric acids. Now, when we start mentioning acids, you say, acids probably aren't a good thing. Well, when we deal with acid rain, or you could just see it called acid deposition, meaning that it's rain or snow, some areas damaging effects are occurring to plant leaves, and the chemistry of soils and surface waters have changed. There are lakes in places where the acid content has brought the pH so low, it is so acidic, that not only has the plant life gone, but the animal life is gone as well. Why has the animal life disappeared? Well, one reason because the plants aren't there, but also because the water is so acidic that the fish can't live in that water anymore. So this idea behind acid rain or acid deposition means that the stuff that's being released into the atmosphere from burning fossil fuels is being picked up by the water. And then when that water turns around and releases itself, so in other words, precipitation, whether it's rain or snow, you've got all these particulates that are falling, but now they're in the form of something like sulfuric acid. Well, when sulfuric acid falls, obviously that's going to have an effect on living things. We don't do well in a solution of sulfuric acid. So it's doing some major damage to the environment. What's another one? Ozone depletion. We talked a minute ago about ozone, and we said ozone's in the upper atmosphere, helps to keep the ultraviolet radiation out of the Earth. Well, that's great. Pollution caused from chlorofluorocarbons, or what we refer to as CFCs, are destroying that stratospheric ozone layer. Well, where do we get CFCs from? CFCs, or again chlorofluorocarbons, are released from cooling units like air conditioners and refrigerators, aerosol spray cans, and from the burning of certain plastics. So the biggest cause of CFCs was aerosols for a long time. Those are the cans where you push down the button and it sprayed out, like hairspray from the 80s. Everybody had big hair, let's spray our hair up. Well, at the time, those spray cans used aerosol as the propellant. That's what got it out of the can. Well, when they realized that these holes were being put into the ozone layer and that now those ultraviolet rays could come through, they said, wait a minute, we can't allow this to happen anymore. So companies went through and stopped making cans or aerosol spray cans with CFCs helping to propel that fluid. So it was something that was done on a production level, not so much on a consumer level. You didn't have to make the choice to buy CFCs or not to buy them. They just went away altogether. And the good news is, from the late 80s until now, a lot of that ozone has come back. We are better protected now than we were before. Well, why do we care? Ozone depletion leads to an increase in skin cancer. You know ultraviolet rays are what cause skin cancer. And cataracts. Cataracts are the thing where you start to get this weird film over the lens of your eye. They can do surgeries, but why have the surgery? Let's just not get the cataract to begin with. So by rebuilding the ozone, by putting some of that ozone back, it happens. It naturally will do that as long as we don't have these CFCs eating holes in it. And that's why if you throw away a refrigerator, you've got to make sure that it's standing in a certain position, you have the gas drained, all of those things. That gas is what helps to cause the problem. And that takes us down to greenhouse gases. Greenhouse gases, remember we said carbon dioxide, methane, water vapor. Burning fossil fuels is what releases those greenhouse gases. Burning a forest releases those greenhouse gases. Remember, if you burn wood, you're releasing carbon dioxide and water vapor. Well, if we burn fossil fuels, coal, natural gas, we're releasing carbon dioxide and water vapor. Those things go into the environment. Now, where does the methane come from? Agricultural practices, like raising cattle and other farming methods, release methane. So we have the methane, the carbon dioxide, and the water vapor. Again, remember, greenhouse gases, they go into the environment, and they keep the heat in. Now, do we want some greenhouse gases? Of course we do. We don't want our Earth 30 degrees cooler. However, the problem is there's so much greenhouse gas now that we have an issue. So the greenhouse effect is we're trapping the heat in because of those greenhouse gases. That's okay. The issue becomes when they build up too much. And when they build up too much, that's where we end up with global warming. Now, global warming, greenhouse gases. Greenhouse gases are what cause the greenhouse effect. The greenhouse effect, if we get above the normal temperatures or if we have too much of a greenhouse gas, now we've led to global warming. That means that the Earth is heating up beyond where it should be. Now, will there be some fluctuations in temperature? Of course there will. So what is all of this commotion about global warming and climate change? What it comes down to is we're speeding it up faster than what it would normally do itself. Nobody's saying that global warming wouldn't occur naturally, but because we're releasing so much carbon dioxide, so much water vapor, so much methane, it's happening faster than it otherwise would. That's truly the problem. So some of those greenhouse gases are necessary. Excess greenhouse gases build up, and that's what contributes to global warming. Once you change the temperature, that can change the temperature of the water, can change the densities of the water when you start releasing some of the fresh water from the frozen ice caps into the ocean. When you do that, you start to change the water patterns. When you change the wind and the water, you're changing the global climate pattern. And that's why sometimes you end up with screwy temperature things that shouldn't normally happen, or weather situations with snow or rain that shouldn't normally happen. So everybody says, well, global warming, I should be getting hotter. Well, not necessarily, because it simply could be because of global warming, your weather pattern is just different. Maybe in a place where you don't usually get cold weather, you're getting super cold weather. That could be because of global warming. And you say, wait a minute, why are we calling it global warming if it's making it colder? Well, because global warming is ultimately what's happening, but now when you look at the local area, it could be changing your climate for that area. So global warming is a huge thing, and what is it caused by? Well, part of what causes it is this whole idea of greenhouse effect. So we're speeding up how soon or how quickly the temperature is going to rise. So finally, and I think what we can say in summation here is that improving air quality is difficult because air doesn't stay in one place, nor does it belong to any one person. No country can say air belongs to me. We can't say that. It's air. It goes all over the place. So automobile emission standards and clean air regulations have improved air quality in certain regions. Efforts have changed the atmosphere for the better. A good example of that would be way back when they decided, okay, we're done with leaded gasoline. They used to literally put lead in gasoline. That's why when you go to the pump now and it says unleaded fuel only, they did actually used to have lead in it. They stopped doing that. Imagine what was being released into the atmosphere when that gasoline was being burned in a car or in some other engine that was burning that gasoline. Obviously, that wouldn't be good stuff to release. So it's those types of things, those regulations, those standards that have helped to keep our air cleaner than it is. Because unfortunately, the air moves all over the place. So even though we may try really super hard here to keep our air nice and clean, don't forget we're getting the air that's coming with our weather patterns. So whatever's in that air comes here to us. So it really isn't just a local effort, it's a global effort when it comes to air quality and air control. I hope that answers some questions and narrows down some of the information that you need to know on air quality and pollution controls. Have a great day.